One of the major themes I'm hearing recently in the last 12 to 24 months is that product life cycles are reducing. And I think some of that's led by consumer demand. I think that some of it's led by the pace of technology advancements. But what it's definitely leading to is shortened development times. And Kevin and Rudy, I think both of you alluded to that during your introductions, that over your 30-year careers, you're seeing these lead times being compressed within engineering. And I'm reminded of a conversation I had with a VP of engineering in the automotive space a few weeks back. And one of the things he said to me was when he started his career about 20 years ago, the time to develop an automobile was somewhere in the 6-7 year range. And if he fast forwarded to 5 years ago, that was cut down to a 4-year development process. And what he's seeing today in the marketplace, with the disruption of EVs and different sorts of companies that have entered the space, is he's pushing his team to develop automobiles within 24 months. So a really dramatic shift from 6 years to 4 years to 24 months. And what that's forcing organizations to do is think and work differently. I'm seeing a lot of engineering organizations and enterprises as a whole really think about how they're being proactive in their behavior, right? What sort of early insights can they get before they move to even the prototype phase about weight or manufacturability or cost even on, is this product worth pursuing? Is it not worth pursuing? And knowing very early on. The other thing that I'm seeing is this is forcing organizations to think about how they're collaborating and the tools that they're using to collaborate, both internally and externally. When I think about internally, I'm reminded of when I started my career in the aerospace engineering segment of the term just throwing it over the wall, right? We would take our design, we'd throw it over the wall to sourcing, and they would do what they need to. And when we think about cutting product development processes in half or by two-thirds, the idea of throwing it over the wall can't exist anymore. And we've got to have a really tightly integrated engineering, sourcing, quality organization. And when I think externally, we've also got to focus on how we're interacting with our customers and our suppliers, right? It is truly one integrated supply chain that your organizations play a role in. And how we're interfacing with those customers and suppliers. The chart I have on the screen here is based on some work done by the consulting firm Kearney on some of the shifts that they've seen through the engineering process over time, right? Starting with the traditional approach, the waterfall resource focused engineers. And then I'm sure you guys through your careers, you've seen some of these buzzwords as well, right? Lean engineering, agile engineering, the idea of modular architecture, driving cycle time reductions. When we look at agile, looking at the customer value focus and open ecosystems. Where I really want to focus today's conversation is around the digital thread, right? And the move to digital research and development, where the customer and suppliers are part of that development process. There's no idea of gathering requirements, taking them from your customer, doing your design work, and then flowing them over to your suppliers. It really is a single integrated digital team with that system level integration, right? You're able to take advantage of that CAD model to do things that 20 years ago, perhaps you'd never thought of. And then layer on top of that, the AI and automation piece, and the design ecosystem looks a lot different than it did even a decade ago.
In the last couple of years, we implemented a PLM system. Before that, we only had drawings. Yeah, we had the 3D models, but they were hidden somewhere in a closet and only engineers had access to it. So the drawings, that is what we were communicating with. Now, if you look at a 2D drawing, determining manufacturability is quite hard, or serviceability. It also means that we only got feedback from service engineers, from manufacturing engineers on the manufacturability and serviceability once we started ordering the parts. But like I said in my introduction, if you then have to make changes You have to make the design change, you have to order parts, the lead time of the parts, you get them in your hands, and only then you can give feedback again. So we realized that besides having a much better integrated product lifecycle process, that having access to the 3D models for all the stakeholders is extremely important. So that was one of the driving factors for implementing PLM. So now everybody in the company, if they have the right access, can see the 3D models. And that allows people to give feedback real time while the engineers are still working on it, on their designs. And so, like I said, that started with manufacturability and serviceability. But now with aPriori, we're also using that for cost analysis. And again, the same story is true. Although cost is a slightly different aspect, because we will not stop with releasing a product if not all the cost targets are met. But the time to profitability is significantly shorter if you take cost really into the design phase. So that's where another advantage of having all those tools available early in the design phase really starts playing an important role. And we see more and more possibilities of working with the 3D models. If you look at traditional field instructions, maintenance instructions, you see it's a lot of text with a few pictures. Pictures are outdated by the time that you take them. But with the 3D models and using the 3D models to break it down in, or use them really to very visualized 3D based instructions, also shortens the time to market. It shortens the time it takes to create those instructions, but it also is much easier to consume, to use for manufacturing technicians and field service engineers alike. So we see a lot of opportunities of working with 3D models and making that available for all the stakeholders.
Kevin, I'm interested in Halliburton's journey. Was it guided by something similar?
Yeah, I think probably all of the above. I mean, time to market, customer demands becoming more urgent. We'll use that word. We focus a lot on engineer to order. And so our projects come in all different sizes, from very quick changes to align our product with the customer's particular thread solutions on their wells, that type of thing. So our projects tend to vary pretty considerably. I think for us, what we recognized was that there was a lot of disjointed activity in our design process and a lot of redundancy. And so you have all these tools that we're using, whether we've had CAD and PLM for close to 25 years now, but the way we implemented those tools, I think over time has started to kind of the methodologies that you put in place to use them have potentially started to make us less efficient today, because we have to enter information in one system, put it in another system, and put it in another system. And then how that information gets utilized when it goes to other functional areas in the organization, whether it's manufacturing, whether it's business development, whether it's operations. So I think the driver for us really in our most recent push is all about, it's not just the applications that we're selecting to use, it's how those applications integrate with one another and how they can communicate with one another with less or no human interaction. A big limitation of drawings is the fact that I have an engineer who spends a lot of time to create a drawing, put GD&T on a drawing based on their interpretation, the best way to communicate the design standard to a manufacturing engineer, to an operations engineer, or to a customer, right? But then because that's a document, that customer, that manufacturing engineer, that operations engineer has to interpret through the language of GD&T what all that means. And you can have disconnects in those various interpretations. Some of the new tools, model-based definition, like that Rudy mentioned, what they offer is the ability to standardize across those functional areas in what the interpretations of a particular geometric callout is, or a particular piece of geometry. And so then when you start to talk about integrating other applications like aPriori, it becomes very important that that tool integrates with that workflow, right? So that it's not just I have to do work here in my CAD system, and I jump over here to aPriori, and I might have to do some some redundant work to make sure that the models talk to each other. So that integration is really important, and the ability for those tools to talk to each other seamlessly.
I'm interested in how you guys have seen the shift to using models, and perhaps using models with your suppliers and customers, the benefit that that's led to for both of your organizations.
Yeah, I can answer that for the semiconductor industry. I think depending on where you have your manufacturing, not all our supply chain is really capable yet of using model-based definition. So we are, I would say, in the middle of a transition, or even at the beginning of a transition, of using the 2D drawings and switching that really to using the 3D models without the need of any 2D drawing. We see some initiatives with some of our colleagues in this industry that are taking bigger steps towards using the 3D models. But we see in our supply chain that still the majority relies on the 2D drawings, especially when it comes to programming their inspection equipment. We do already for quite some time provide the step files as a neutral file to program the tools, but also always for inspections, people still ask for 2D drawings. So we are thinking how we can jumpstart this whole model-based definition, and so that we don't rely on our suppliers, because then we rely on the slowest one, and we rather serve the fastest one who can adopt this new technology. So there we definitely see challenges on the receiving side.